I want to show you what I would consider one of my favorite demos in Qwik. I love this demo because it demonstrates how when you just follow the normal practices of Qwik, you automatically get the optimal behavior without the developer really having to do anything. And so the demo consists of simply just a bunch of items which force a clock to be below the fold. And you can see that the clock updates every 1 second in order to show what is the current time. So that in itself is not that interesting. Now, what is interesting is that if you look at the network tab, you'll see that there is no JavaScript present. We are running in the dev mode, so I'm filtering out Vite, just in case you're curious, but no application code is actually present. If you scroll down, you'll notice that as soon as the clock shows up, the JavaScript shows up. There's really two parts to it. There is the code that knows how to update the clock every 1 second, and then there is the actual framework that does the re-rendering. So besides those two things, nothing else has showed up. Let me refresh that again. No JavaScript. Now, the interesting bit is what is actually the developer experience. So let's look over what the developer had to write. One of the things you'll notice is that Qwik is very familiar for those of you who come from frameworks such as React and are familiar with JSX. The only difference you'll find is that we will have these extra dollar signs. What the dollar signs mean is that this particular code is a place where serialization needs to happen and that where lazy loading of the code or lazy execution of the code can happen. And so just like there are use methods and special rules apply, there are special rules about the dollar signs that you have to be aware of. But once you have that, you don't have to think about it at all. The other thing to point out is that these dollar signs are part of the API. So it's not like you can forget to put them in. If you forget to place an API dollar sign method, TypeScript will immediately point out that this is not a valid property of the system. Now, the way this works is that we have our component and we have our paragraph. And notice you can click on this paragraph, and I'll show you that in a second. And then below here, we just list a set of items. And finally, we render the clock component, which is described below, which I'll show you in a second as well. So let's focus now on this onClick. What's interesting about this onClick is that this closure here is really the only thing that needs to be executed when you click on a button. But notice, in order for the system to get hold of the closure, it needs to execute the top level component. And as it's executing the top level component, then it will be able to get hold of the closure reference. And at that point, it will be able to execute it. This is how classical frameworks work. But Qwik is different. Because there's a dollar sign, this tells the optimizer to extract this code out into a separate importable thing. And as a result, an interesting thing can happen. I can go to the source code, I can click on this button. Notice when I click on it, the console prints out test. But if you go to the clock, you'll notice that the only code that's downloaded is just the code that was necessary for printing that out. As a matter of fact, even the framework itself is not downloaded. So somehow, Qwik on a server was able to transform the code in such a way that this particular function became importable from a top-level scope. And as a result, not only was it importable, it was extracted to a separate file so that the system can download just that thing, right? The end result is that at any point, if you look at percent code coverage, you'll see that we essentially have 100% code coverage. Now let's look at what happens when the clock comes into view. Notice when clock comes into view, immediately clock, the client effect code shows up. So let me show you that inside of the source code. So again, this is a top level thing. This points to clock, and the clock itself is a component. It says, well, in order for the clock to run, I have to get these styles to make sure they're available. I'm going to have a store where this is a reactive store, and this is where we keep essentially the degree angles for the individual hands of the clock. And we have a client effect that basically says that in 1 second, an update function should be run, which recomputes the angles of the clock. And finally, we have a JSX that basically says how the clock should be rendered. Now, what is interesting over here is that when we actually show and render the clock, notice what actually gets downloaded. We download the use client effect. Well, that makes sense because we have to run it. And we have to download the framework itself. Well, that also kind of makes sense because the framework has to update everything over there. But nothing else got downloaded. And that is kind of strange, isn't it? First of all, we didn't download the styles. We did not download the use store. And we didn't even download the JSX associated with this particular component. Instead, the only thing that really downloaded was this use client effect. And this use client effect is kind of required, right? This is the actual behavior that updates the clock every 1 second. Now, the other thing that's kind of interesting is that the use client effect doesn't execute until the clock is scrolled into position. Now, why is that, or what did we have to do special? Well, it turns out nothing really, because use client effect says run this code on the client. And so the next obvious question is, well, where exactly should the code run? And in classical frameworks, the answer is very straightforward. Well, the code just runs as part of hydration. Yes, but Quick doesn't have hydration. Quick has resumability. So where exactly should the code run? And if you think about it, there's really only two options. You can either run the code eagerly as soon as the page loads, or you can say, well, this code should really run when the component becomes visible. And because effects are usually things that you want to do once you render on the client, the default behavior should really be execute this behavior only when the component comes into view. You can override this behavior and you can choose different behavior in here as well. But the default one is that it does it only when the component becomes visible. And it's kind of super interesting, right? Because what you get out of the box without even trying is this nice behavior that, hey, clock needs to update, but guess what? Clock is below the fold. It's irrelevant. So don't do it just yet. When the clock scrolls into position, immediately as soon as the clock shows up, download the code that's necessary, download the framework and update. Now, there's another thing that's kind of interesting, which is how does the framework know how to update the clock if it didn't download the JSX, right? Most frameworks know how to do this because of the JSX. How does Quick know how to do that? Well, it's because our store is reactive. And what's actually happening is that we store information about the clock in form of signals. So if you go to the elements and if you find the JSON that stored everything, let's see, where is it? It's right here. You will notice that in here are encoded what we call subscriptions. And what this says is that for a particular object, if any of these properties change, hour, minute, or second, we actually have to update the style property on the object B, C, and D. Where are these objects? Well, they're right here. If you go to div, if you go and find the clock right here, you will see that B, C, and D are these divs right here, and these are the styles that it has. So as soon as the clock comes into view, the system knows that it needs to place the style information on this particular DOM element. Now, I want you to think about, like, how would you do that in existing system? Like, would that work? Like, it is not that easy in normal systems to delay downloading code and to only download the code when something becomes visible. Sure, you can set up your own intersection observer, but it's extra work, and also it's not easy to lazy load code as well. And so in normal systems, people will look at it and say, you know what, in theory this would be better, but it's not worth the trouble, and most of the times people just won't do it. What I find fascinating about Quick is that the developer didn't even have to think about it. It's just a natural outcome of how the developer puts the components together and how these components naturally behave. Now I want to show you one more thing. Let's refresh the page and let's find our clock again. And what you'll see is that the clock has a property called QVisible, meaning this is a synthetic property that the Quick sends out saying this particular component has become visible. We can actually mess with this and we can change this to click. And now notice what happens when you scroll the component into the view, it is not updating. And if you look at JavaScript, no JavaScript is actually executed. But the moment I click on the component, immediately the component wakes up and starts behaving as you would expect.